study computer science because he was intrigued by systems. His courses and internships during his undergrad morphed this interest into a passion to empower people, businesses, and communities. He has since pursued knowledge with this goal in mind, and so far he has been able to apply his expertise in big tech firms and the financial services industry on 2 continents. He currently works at Google Cloud in Ireland as a site reliability engineer. Previously, he worked at Team Apt Limited, where he built internet banking and merchant management products for Nigerian banks. So you're welcome to the call, Ayomide. The next voice you'll be hearing on this call is Ayomide.
Cool, thank you. It was very strange to hear me being introduced. But yeah, hi everyone. Thanks for joining this. So I guess like the main idea for this these calls would be to try to solve questions, well, as many as we can, and also like answer general DSA questions that people have. So I'm trying to find the link for the, give me one sec, for the documents, Google Forms that we opened. I'll share my screen in a sec. Interesting. So I think I need to rejoin. My Chrome is telling me I'm not allowed to share my screen. I have no idea what that means. But
Okay, just hold on. Adora, please enable screen sharing.
Yes, I mean, it's done. You don't have to rejoin.
oh, okay, cool. I didn't know that was something I could disable. Cool. All right. So it looks like there are 2 forms. Can people see my screen? Yeah, I think so. So I'm just going to quickly go through. So we open like up a form for people to ask questions, and I'll just quickly go through it to see if there is any interesting thing here. And like after this, we'll just like solve 1 or 2 questions. Cool. What are the major data structures and algorithms? And do you have a guide that discusses the application in simple terms? So yeah, I mean, whoever asked this question, please just check the Slack group. We spoke a bit about this last week. I don't want to repeat it, but there are a few links. I have like a GitHub repository for this. Yeah, it will probably help you. You can text me, you can mention me in the group if like you can't find it. What's an effective approach to learning destruction algorithms? How to come up with solutions to problems you've never seen before. So, what's an effective way to learn? I think learning about how the data structures and algorithms work, like what the essence of them are, what the essence is or are. I have no idea here. But yeah, the essence basically, and how to come up with solutions problems you've never seen before. But that one you just need practice. There are strategies you can like ways you can approach questions to help you see the big picture. I should zoom in 1 sec. Is that zoomed enough? I think so. So how to come with solutions problems you've never seen before. So I would say practice would help, but then also having an approach to problem solving, like how do you approach a question? You know, do you make sure like you understand what the question is asking? Do you clarify? Do you you know, like ensure like you understand the constraints? So yeah, I mean, I guess like as we go on, as we solve different questions, you would see how I do it and how other people do it, because I'm not the only one going to be solving questions on calls. Um, I might get some people to help me out, but I think it's important that we all do it together. Um, we're trying to like empower people to learn data structures themselves. So like I said, so whoever this person is, I have a repository on the group chat where I explain data structures and algorithm. Let me see if I can get to it. So yeah, so I have this like I have this repository where I took the time to explain structures. So a linked list is explained there, and I think it's pretty well explained. So if you read this, but you still have questions, then ask, like, let me know in the group, right? Um, but yeah, we would probably not be explaining what the linked list is today. Is data structure also a must for a role in DevOps engineering or cloud computing? Well, I would say that like having knowledge of it to definitely help you in the long run, to help you come up with like solution problems, to help you in the types of problems that you don't need to think too much about. Like in DevOps engineering, if someone asks you to like write a config file and you have to write a config file, or like they need about something and they're very specific debugging steps. Like as long as you're doing things that are already well explained, maybe you don't need like to know what are data structures. But if you're going to be solving new problems, you want to think critically about problems. I think that understanding data structures and algorithms is important in DevOps engineering, software engineering. But I mean, there are people that are earning money as software engineers today that haven't necessarily, taken the time to study. So it depends on what you want to do. I have issues speaking out in my thought process. So this would also be solved with practice. Hopefully these kind of calls can help. What are algorithms? Interesting question. Algorithms are a finite sequence of instructions that have a specific outcome, something like this. Develop an algorithm to find the shortest distance between 2 points on a 10 by 10 2D plane. bearing in mind that random points in the plane may have obstacles. That's an interesting one. Develop an algorithm to find a shorter distance between 2 points in a 2D plane, bearing in mind that random points in the plane might have obstacles. Okay, we can do this. Not really. I really appreciate Adora's efforts in bringing valid people. Same. I would like to give an explanation of recursion and backtracking. Okay. What DSAs are used the most in real-world applications? These are we answered a lot of these last week, so I kind of want to make sure we're using the time well. I hope examples will be on real-life projects. I feel stressed solving Tower of Hanoi, Palindrome, and others. Sorry. Yeah, this is good. I mean, maybe we would try to find real-life application of these things, or try to frame the questions around real-life scenarios. Those are good. We can try that. Just started studying DSAs, hoping to get a general understanding of topics. Yeah, all right. I'm trying to learn, but I understood it. Okay. Can you explain time and space complexity? How to determine an algorithm? How do I make consistent in solving these structures? Best way to solve. For consistency, I would say that the ways that helped me was, having like a group of people I solved with, then having a specific time of the day that I solve questions, and also having a plan. Those were the ways that helped me. So maybe that would help you. Can someone really get good at DSAs in a month? Like I said, it depends on where you are in the journey. One time complete a B tree and try. Okay. So I think most time I understand how algorithms work. Implementing an issue. How do I get through to it? I still struggle. Okay. Cool. So something I'm going to do, I think, before the next time is to try to like group questions that are similar so that I just present similar questions. I don't think going through like this is the best way because there are a lot of questions that are kind of similar, saying the same things. So yeah, I'll do that before the next one. But I want us to solve questions on this call. And there was one that I saw here that could be interesting. So let's see. So I hear Replit is good. I mean, I use Replit. So last time on the call. So I'm going to try and make this like light. Sorry, how do I change the I should be able to change the settings, right? Oh, there's a sun and moon icon where sidebar. Oh, this one. Okay, cool, nice. All right, so yeah, we use this. So let's see, what are the questions here? One sec. There was one I saw about 10 times 10. Yeah, I don't think this question is complete, but let's see what we can get from it. Develop an algorithm to find the shortest distance between 2 points on a 10 by 10 2D plane, bearing in mind that random points in the plane may have obstacles. So let me see. Let's say that I have, how do I do this? 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so I mean something like this. So I'll have this 10 times or something, right? And so on and so forth, like 10 by 10. So I'll count this 10 times and have this 10 times. So find the shortest distance between 2 points on a 2D plane. So I'm guessing that you would give me the 2 points, right? So I would have point 1, point A is, I don't know, XY or something. And point B is X1, Y1. So I mean, I have no idea how to solve this question at the moment. So for context, like this is to, I guess, help with people that ask questions about how to solve questions that they haven't seen before. So generally, one sec, I follow like a set of coding steps. I'm going to copy it out and put it somewhere. Does this work? Yeah. So I follow a set of coding steps. Just, I mean, I don't follow everything like this all the time, but yeah, it usually helps. So repeating the question in my own words to make sure I understand what the question is saying, then verifying the input and output. Then I think about how I want to represent the data, which is kind of what I started here, with this one. Then I think about edge cases. Then I think about an approach to solve the problem. In an interview, before you actually like start writing code, you want to make sure that you and your interviewer agree on an approach. So if you come up with one approach, but your interviewer thinks that it might be a more efficient way, then they could tell you. And at that point, you want to come up with something more efficient. Also, in general, as you continue solving, you would also be thinking of more efficient ways to solve problems. So that also comes with practice. Then once that is agreed upon, you write the code, then you test it and talk about space and time complexity, right? So yeah, hopefully like I can answer the space and time complexity bit as well if this question is solvable. Right, so bearing in mind that random points, so there may be random points on so I mean, I'll just represent obstacles as like asterisk or something, right? So this person is saying that there might be just random points on the plane that might be obstacles. So I should find shortest distance between 2 points in a 10 by 10 2D plane. So when I think about shortest distance, right, the first thing that comes to my head is using breadth first search, because breadth first search is so if you think about a graph, I don't know if like drawing this would be, I feel like I should use what's the name of this thing again? Excalibur to explain this. Give me a sec. Delete. So let's say that we had a graph, right? Something like this. Yeah, something like this. And I mean, it kept going and going down and going down, right? And I want to find the shortest distance between the roots and let me connect a few things together. All right. So I think I can have this and this as well, just for emphasis here. All right, cool. So let's say the question here is to find the shortest distance between the root. Like, what is the shortest distance between the root and a leaf, right? So I want to see, like, obviously, like we can see that the shortest distance between um, the root and a leaf is 2. So 1 and so from here it goes here, then here. Right. This is the shortest distance from the root to the leaf. But how do I find that like Van algorithm, right? There are two ways that there are different ways to search a graph, but there are two main ways. So there's like depth first search and there's breadth first search. So if I started with depth first search, depending on like what direction my algorithm goes first in, so I might either go left or right. So depth first search means that you need to go to the deepest place. So you go in a direction and you keep going, until you get to the like deepest depth. I don't know if that makes sense, but the deepest node in that direction, and then you keep coming back, going back to the previous step as you like once you get to the deepest node, then you go back one step and see if you can go in another direction, and so on and so forth. So if we start with depth first search, we'll go from here to here, then here, then here, then here. With depth first search, we could find the shortest distance as well, because after we've searched like all of these, then we just count that, oh, the distance from here to here is like 4 or something. We record it. Then distance from here to here is 2. We record it. Distance from here to here is 4. We record it, and so on and so forth. But like with breadth first search, we would check that at this root, from this root, we check both children. We check if both children are leaves. Both children are not leaves, so we know that the shortest distance can be 1, right? So from the root, the distance to each of his children is 1, right? Then since both children are not leaves, then you now check the children of those children. So it means that from this one, you check its left child. This is not a leaf, so you just leave it. But this one is a leaf, right? So at this point, you've reached like a leaf. Once you reach a leaf, that's the shortest distance you can possibly have, because you know that from the root to the first set of children, there is like both of these are not leaves, so the distance can never be 1. And as long as you find a node that is a leaf in the next step, which is 2, then that is the shortest distance. So it doesn't matter if like it doesn't even matter if like the next node is a leaf. As long as you found one node that is a leaf at this point, then that's your shortest distance. Yeah. So in general, like when you hear like shortest distance in a problem, you want to think about breadth first search, whether it's a graph, whether it's a matrix, whatever. You want to think about breadth first search because that helps you find the shortest distance. So yeah, so I'll just think about it like this. I don't know, something that this question doesn't tell me is like what directions I can go. So it doesn't tell me if I can go only like left and right, or if I can go in all directions in the graph or something. So if I want to assume that I can go like left, right, up and down, that means that from each point, so left, right, one sec, up, down. So if I'm going left from a point, then that means that I'm going to do, what am I going to do? X minus 1, abi? So that means I'm going to move from xy to x minus 1y, something like that. So it means that like if I'm at, I don't know, I hope that's clear. Like, so if I'm at a position and I want to move to the left-hand side, then I need to subtract x by 1 to move to the left-hand side, to move to the left position. So that's what that means. Then from xy, if I want to move to the right-hand side, then I have to do x plus 1y. then for up down, I mean, we kind of repeat the same thing, but um, with y. So x, y minus 1. This could be a bit confusing if you're thinking about this in terms of like, graphs that you draw in math, because in graphs that you draw in math, x increases upwards, but in matrices, x increases downwards. So yeah, just so that like, you're not confused. Cool. So you're telling me that basically from each of these positions, I'm able to, so these are all the direct children of standing. We want to find so if from xy, let's say this is xy, in our graph, that's a, it's actually be nice if I had test cases to test this against. So I don't know who sent this question, but if you have test cases, please send it. So that like we're sure what we're coming up with is actually correct and I don't lie to you guys. Yeah. So from xy, I can go in 4 directions, and we use the same idea, right? Yeah, rows and columns. Exactly. So in xy, yeah, right. I'm using exactly. I guess, yeah, it was me that actually was confused. So x would be row, and y would be column. Exactly. Hmm. No, it's actually the other way around. Hello. Yeah, but it doesn't matter too much because we're still doing the same math in for both of them anyway. But yeah, so for x, I was saying that when you're here, for like if you're in this position and you want to move to the left, you can subtract x by 1. If you're subtracting x by 1, so you're moving from this column to this column, so that means x is column. Then y, yeah, up and down is y needs to be row for that to make sense. Okay. Anyway, that's fine. But yeah, we're using the same idea. So from each point, we can go left. We can go to we can go in 4 directions. And in each of those directions, we can also, try to find. We'd also now try to visit their own children until we get to a point that is this point. Immediate things I think about that might be a bit troubling would be I want to make sure that I am not going in what do you call this thing? An endless cycle? I don't know if that's the word. Endless loop, right? Because this feels like a thing that could put me in that kind of position for some reason. Yeah, someone said that to prevent using an endless loop, I want to use a listed array. That's something I've thought about for sure. But whether or not we'd use that, we'll see. We'll see if it fits. But endless loop is something I'm kind of worried about. What else am I worried about? Yeah, so listed array to keep track of the listed node would help. Someone said overflow. So yes, I want to make sure that I do not go out of my boundaries for the 10. So it's a 10 by 10 2D plane. This math, if I don't check it, it's very possible that I go out of the boundaries of a 10 by 10 2D plane, right? So yeah, like ensure I'll just say overflow, matrix overflow. So that's a good one. I wonder what those. I think we can start with those. If anyone else comes up, we'll see. So what's one way we could do this, right? We could, start at position, start at X and Y, X, Y, visit its children, um, then visit your children, check if one of them is point B. If yes, return, right? If no, then visit the children's children and repeat, right? So that starts out a bit simple, but let's see if it actually works. And 10 by 10 is actually like quite big. So I want to see if I can reduce the scope a bit. And to see if can we pick a question from HackerRank or LeetCode that has to do with BFS? Like, do you mean in place of this question, Ehis?
Yes, because the question is kind of like there's no much scope to it. So I'm saying if we could take something from this code or HackerRank that has like constraints and a well-defined structure, it would help us properly understand.
Okay. I mean, we could do that, but
I think we should finish this off first. We've already gone far into this.
yeah, we have gone far. So I mean, like usually, right, in interview questions I've been in, right? In interviews, sorry, I've been in, they would give you like a question like this, just something random, like they could even give you without examples, they could give you without constraints. And so usually this is the point where you're asking questions. You ask questions so they make sure like you actually know your own constraints. You ask questions to make sure you understand what the input and output is. You ask questions to make sure you have examples you can work with. So this is actually like usually a good starting point for interview type things. They'll probably not give you like all of the things you need. You probably need to ask to find out. But yeah, I agree that the problem here is I don't know the person that asked this, and so I'm not able to like ask the person questions. But we can make the assumption that. Sorry.
Okay. You can go on, please.
We can make assumptions as we go, and see how far we can get. I'm pretty sure we can define constraints ourselves though, like if we need to. Yeah. So exactly, like for example, I was going to say, 10 times 10 is a bit big. The same ideas kind of apply even if it's like 3 by 3 or 4 by 4. And that's a bit easier to work with. So I want to see if we can work on an example like that. So give me a sec.
Okay, I just want to say I think I was in an interview with Google, and this was the question they gave me exactly, but it was more like a 3 by 3 matrix, and the zeros the stars were represented with 1 and the dash was represented with 0. And it was a bit difficult, and I'll post a
Okay.
link to the solution I saw online.
I need to declare at this point that this question I'm solving has no, like I'm not solving because I have an affiliation with Google. I'm solving because it was on the Excel sheet or the Google sheet. So yeah.
I didn't have an affiliation with Google actually. So sorry. I shared the link on the chat of the similar
No.
question on the Google.
Okay. I'll probably not check that until we're done so that we can work through the question together. But cool, thanks for saying. So, I mean, I know that there's a similar question called island and something. I can't remember. something like that. I've seen something like that on LinkedIn. But I think the difference between this question is this one I feel like the island one that I saw anyway, or I have solved like previously, you can move like left, you can move right and down or something like that. And so because you can only move in two directions, like if I could only move right and down, it means that if I'm at this point, if I'm at this point, I don't know why is it highlighting everything. But if I'm at this point, I can only either move right or down, right or down, right or down, so on and so forth. So that kind of limits the way I move. And I would probably not have, issues with like an endless cycle or something like that. But because I can move in all directions, then it introduces like an interesting concept, because if like I'm at this position and I can move, left, and from the left I can also move right, then it means I can get into a position where I'm moving from left to right and right to left, and that just like becomes a whole thing. But then I also can't just block, like if I say that I'm moving from, this position to left, and because I'm moving from this position to left, I now say that, oh, I've visited this position. I also can't just say that this position is visited for, I don't know why it's highlighting everything, but yeah, this position is like visited forever. So no matter where else in the matrix I try to get here from, I'm never going to be able to visit this node because I've maxed it, I've visited before. So let's say that I was starting from here, for example, right? So for like somehow I got to this position, and this get me at this position has nothing to do with me starting here, and going here. At this position, there's a way that I would get to, there's like a way that I would traverse this matrix that I would be able to get to this position, right? So from here, right, I could go left, left, and down. But then if I've marked this as visited from, some previous step, I wouldn't be able to visit this node. But this might be a valid way, like a valid path for me to follow from here that would actually get me to my solution. And so it means that the only time I should mark this guy as visited is when it's like in the current context of my search. So I should only mark this as visited when like I am currently, like is in my current path. As long as I'm no longer searching a particular path, I should not mark them as visited. So what does this mean? So let's just imagine, right, that I have two separate directions I could go. Like this could happen in, or another way that I could go is even, I just remember that I could go diagonally, right? I could go from here to here, but I'm just going to assume that we can go diagonally in this question. Hello. So let's assume that I could start from here or I could start from here. I don't know how we got there. This is just an assumption, right? And from here, so from here and from here, let's say we want to get to this point, right? It's possible that, from this point, let's say that this is the point we started from. So from this point, the fastest way to get here is by from here going left, going left, going left, and then coming down. So from this one, I go 1, 2, 3, and 4, right? And I mark this as visited. Now I'm starting from this position, and I want to now try to get to this position. This is the position I'm trying to get. So I'm trying to get to the shortest distance I'm trying to get the shortest distance I can use to get to this position. So I now go from here. I go left, but then I see this as visited, right? This might not be a perfect example. Maybe this is not the path I'm looking for. Maybe this is not the node I'm looking for, but it is in the path of the node that I'm looking for that would help me get to the position quickest or something, right? But the point is that because I've marked this position as visited while I was searching from this point, this when I'm now searching from a very separate direction, I'm not going to be able to get like past to that point anymore. But that should not happen, right? This part should only be marked visited in the context. So as long as I am searching, like all of my search is extending from this node, then yeah, I can mark this part as visited as long as I've reached it once. But if I am starting from another place, like another direction, like this should not be marked as visited because I can visit it differently from this separate context. I mean, all of this stuff I'm explaining is like backtracking. It's called backtracking. I don't know if I'm actually explaining it clearly, but if it is unclear, please tell me. Like, I've never tried explaining this before, actually. But in backtracking, you basically try a path. As you're trying the path, you want to make sure you're not going in an endless cycle. So you mark each point you visit as, like each node you get to as visited. But as long as that path doesn't work, or as long as you finished like searching through that path, you want to make sure that every node that you've marked as visited is unmarked so that it is not visited. So that when you try like a different path, the different path will see those nodes as unvisited, so it can visit it. So that's basically backtracking. So backtracking, you try different paths to see which one is the best one. Yeah. So I feel like we might need to use backtracking in this question. That might be like an early assumption. I don't know, but let's see. So let's say that what did I just do? Okay. All right. Let's say that my point A. So let's say I'm using like a 3x3 matrix and sorry, this is 4x4 matrix instead, right? And my point A is what? I can say my point A is 1, 1, and my point B is what? My point B can be 3, 4, I guess. So 1, 1, 3, 4. Right. Okay. So this is, where's 1, 1? This is 1, 1. Point A, and this is asterisks represents blocks. So they represent obstacles. And I'm trying to get here. So I'm trying to see what is the shortest distance from A to B. So from, let's see something. So from 1, 1, I can go to, so the fastest path, so I mean, a few paths we can see just like by looking with our eyes. We could go from A, we could go up here, we could go here, we could go here, we could go here, and we could reach B. So that is so 1, 2, 3, 4, 5. So if we go in this direction, we would have 1, 2, 3, 4, 5 points to get to, right? So we've seen like a distance of 5, right? If we go, we could also go another way, which is we could go this way, this way, this way, this way, this way, this way, and this way. So we could go A, 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 A. I mean, we can either go here or go here. That's fine. Like, yeah, it's still the same thing. But from that point, it's like 1, 2, 3, 4, 5, 6, 7. So the other distance I saw is 7. So just off the top of my head, or like off based on our based on our eyes, the shortest distance that I can use to get to B is 5 from where A is. But how do we actually implement that? Okay. I mean, I would like to. I would probably want to. Yeah, static obstacles. Cool. So this is where A starts from, right? So we've seen 5 and we've seen 7. So how do we actually implement an algorithm to do that? So if we did, let's try the visit its children, check if one of them is point B, if yes, return. We also want to check for obstacles. So we'll check at some points, I'll just make a note there. Check obstacles. This is also taking, I think, a longer time because I'm trying to explain multiple. Yeah, no diagonal movements. With diagonals, it'll have been fun, right? But I think we can, if we finish this on time, we want to try and finish by 11, I think, this call. I think so. So if we finish this question on time, which we should, then we can try extending to diagonal to see if, yeah, that's something we can do. I don't know. We'll see. So yeah, like I said, we check for obstacles. So let's try to follow this like algorithm to see if it will work, right? So we can go from 1, 1. We can go to, I think that the fastest way would be to, sorry, give me a sec. Fastest way would be to, please let me know if you can see the screen. But I think that using a diagram would be faster to explain this so we can see the different directions. Cool. All right, so we start at 1, 1. Right? So from 1, 1, we can go to, what are its children? So its children are, so 0, 1, right? So that's x minus 1. Then its children are, what else? 2, 1, right? Then its children are 1, 0, and 1, 2, right? So let's try and have 4 children here. I wonder if we can be able to represent this because this is going to be pretty big. But yeah, let's see, sure. So we would have, what do we have? 0, 1. We would have 2, 1. We would have 1, 0. And we would have 1, 2. Cool. So from this guy, we can go in these 4 directions. It's going to be kind of ugly, but I mean, we get the drift. All right, cool. So what did we say we'll do next? We'll check for obstacle. No, I think we should check if one of them is point B first. If no, if it is not point B, then I want to check if it's an obstacle. If it's an obstacle, I want to ignore it. So I check if what is point B, 3, 4. Are any of these 3, 4? No. So I definitely need to keep going. But what is important to note is that the distance here, like the distance here is 1. So distance at this point is 1. So we're doing like a breadth first set type thing, right? So distance here is 1. So from the root node, which is 1, 1 in this case, to its children is 1. All right. So let's keep going. Then, so it's not like none of these are the points we're looking for. So if no, then we now go to each point. So 0, 1, we now check if 0, 1 is an obstacle. 0, 1 an obstacle. What's 0, 1? How do we get to 0, 1? We go left. Sorry, this is 1, 0. Yeah, I think that I'm confusing myself with this like X and Y thing. So I'm just going to replace them as row and column. So yeah, it's a lot easier to think because I keep also confusing this with math, and I think that's bad. So I'm just going to make this R and Y, R and C rather. So everywhere you see X and Y, just think of X as R and Y as C. Yeah, don't worry. Let me just give me a sec. R, C, R1, C1, R, C, Yeah, I guess something just this is also something important to note for interviews, right? You want to make the whole thing super easy for yourself. Don't be like me. Use like the easiest way to remember stuff. RC is easy to think about because I know this is like row. And so 0, 1 would mean going up. So if I'm starting at 1, 1, the 0, 1 is this point, right? 0, 1 is not an obstacle, so it's like a potential point I can visit. So I now yeah, 0, 1 is like a potential point I can visit. So I now try to find the children of 0, 1. So 0, 1 is here, right? Cancel. The children of 0, 1 would be, basically the same thing that we've done. I don't know if yeah, this is going to get kind of big. That's fine. Let's see how far we can go. From 0, 1, we can't we can't do 0 minus 1 because 0 minus 1 takes us out of bounds. So that means that there's one child less. We can do 0 plus 1. 0 plus 1 is 1, 1, right? But 1, 1 is in this path already because that's where we're coming from. So we can't go back. We can't go from 0, 1 to 1, 1 anymore because yeah, that's going to keep like put us in like an end cycle. So this is what I meant, right? So because you like 1, 1 has like we've seen it before, we also kind of ignore that. Then the other thing we can do is to do 0, 2 and 0, 0, right? So yeah, this is the basic idea. I feel like if we continue, yeah, this might take some time. But the basic idea is to go from 1, and at each point we are getting the children and visiting them, and we're checking stuff like, have we seen this a node in this particular path before? If we have, we don't want to visit it again. But if I've seen like 0, 2 here, for example, like let's say that I visited 0, 2 at this point, right? Because I've seen 0, 2 here does not mean that I won't visit 0, 2 when I get here, right? I mean, I don't know if I can get to 0, 2 from here. Yeah, I can by doing 1 minus 1 minus 1. So because I've seen 0, 2 here, does that mean that I won't try as well to like visit 0, 2 from this node, right? Because they're unrelated. So the only time it will matter if I mark 0, 2 as visited is if I am checking it in the path. So because 0, 2 is on this path, I never want to visit 0, 2 again on this path because if I do, I'm going to end in an endless cycle. So yeah, this looks like backtracking to me. So what I want to do, let's try and get to like a solution quickly because time is actually gone somehow. I want to check. So I visit it nodes. Let's see. What do I need to modify? I visit it nodes children. Check if one of them is point B. If one of them is point B, I return. If no, I check if it's an obstacle. I also check if it's visited in that path. Check if point is visited in path. If yes, ignore. So if I've seen that path, if I've seen that node before on that particular path, I ignore it. Just the way I ignored 1, 1 here, because from 0, 1 I can also get to 1, 1. But because I'm coming from 1, 1, I don't want to visit 1, 1 again. So if it's a path I've seen before, I ignore it. Yeah, we need to check if it's out of bounds, but that's something we can check for sure. I mean, yeah, I don't think there's something that's right, but yeah, we'll check if it's out of bounds. So if it is visited, ignore it. If it is not visited, then I want to visit all these children and I basically repeat the process, right? So how do we represent this as code? Oh Lord. I mean, at this point, this kind of makes sense to people, or Like, do I need to like explain something better here?
It's
Anyone
making
can
sense
lead.
to me. It's
Right.
making sense to me.
Okay, cool. Good to know. Thank you. But yeah, if like this is kind of confusing, please feel free to just interrupt. I would do my best to answer your question. So first of all, I'm assuming that our stuff is public. It doesn't really matter. What do we want to return? We want to return shortest distance. So we're returning an int from this method. I would say shortest distance. I'll call it shortest distance, right? Then I want to assume that what we're accepting is an array, an array of arrays. I'll call it a plane because question call it a plane. Then what else? I'm giving 2 points, right? So I'm giving point A and point B. Something like that, right? Okay. So at this point, what I want to do, sorry, no, point A is going to be, okay, that's actually wrong. So point A is going to be point A row, oh good, and point A column or something. For simplicity, I'm just going to call this R. I feel like everyone should know what R is, and I'll call this R1 and C1. Just for context, because calling point A row and point C column is kind of annoying. So I will just call it this. I think we know what this means. Then we want to another thing, right? It's possible that one edge case I can immediately think of is if like the row and column are the same, like the points are the same, right? So if they're the same, then I just want to return at this point, right? So if R1 is equal to, if R is equal to R1 and C is equal to C1, then just return 0, right? But if not, let's go. I want to get children for RC. So how do I get children for RC? So that's R minus 1. Okay, so I'm going to call another method where I think that I can find this, right? I pass plane, I pass R, pass C, pass R1, C1. That's the same thing, but I want to call it again. That's the same definition. At least it should. Okay, now for this, I want to pass in something extra. I want to pass in a visited array, a visited multi-dimensional array, where this would be the plane, the length, right, and plane 0, the length, something like that. So I'm creating like a visited, this will keep track of nodes that are visited in a particular path, right? Like as we go this way. Like as we go down a path, we store the nodes we visited up to that point. Yeah. Something I'm thinking about is the fact that we need to, okay, I guess that doesn't matter here yet. So visited, then I'll just have a visited guy here. All right. Do I have a closing press? No. All right. So now I want to get the 4 directions, right? So left point or left point, yeah. So to get the left, I have to subtract 2 row by 1, right? Can we use a listed array in JavaScript? Yeah, you can. I believe. JavaScript has lists, right? You can use a list of lists. You can use a map. You can use. This is just one way. Basically, what I'm doing is, if they give me an array like this or a multi-dimensional array like this, what I'm using this visited is I'm basically creating a replica of this guy to mark as I visit. Right. So yeah, I'm just creating a replica to say as I visit each point, I just mark as visited in a similar one. So to get left point, I do row -1. Actually, I don't even need to do this. So I just call the find this. So I do find distance, then I do plain. Then I do r -1. So at this point, I am going left, right? I do r -1. I do c. Then yeah, I'm basically just changing. I'm going left, so I'm subtracting r from 1 from r. Everything else is going to be the same. C1 visited. Now, when I visit in a node, I need to mark it as visited here. So I need to mark R and C as 1 or something. So this marks current position as visited, right? Okay, so I go left. Then I go right. How do I go right? I just add 1 to this guy, right? Then how do I go up? I subtract 1 from C, I believe. And down, I would add 1 to C. Please feel free to interrupt me. I would try to explain as I go. Someone said I'm using DFS. Yeah, it looks like I am actually. So I'm going up. That's a good call out. So I'm going up, down, and I keep going deep in there. I would find my shortest distance, but this is not what we spoke about. So how do we change? So I want to go through its children. It's almost like how do I do that? How do I do that? I'm coming. This is kind of how it's coming to me right now. I will try to modify this as we go. Yeah, I kind of spoke about DFS and sorry, BFS. I went on to do DFS. That's terrible. But yeah. Okay. So at each point, I now want to, when I visit, I want to mark as unvisited, basically. I want to make it 0 again. Okay, so what do we do now that we're like calling? So we have a few edge cases, right? If I have visited this guy before, the DFS is in, yeah, I'm coming. So what's the edge case? What's the, sorry, base case here? So as I find as I find distance, as I'm going from each point, I want to increase the distance by 1 as I keep going deeper. And if I ever get to a place where I find the right, so I just keep adding 1 as I go, right? And then when I come out, I find the minimum path. But what if I get to a path that doesn't have I get to a path that doesn't have the node at all, but I've reached like an edge or something, I've reached an obstacle. Like, what do I do at that point? Okay, let's do this one after the other. So if I do get to a point that is, if R is equal to, I basically make this check again. I just return 1 at this point, right? Right. If so that means I found the position. So that'll be my base case. Then I also want to check for if there's an obstacle, right? So if I want to first even check if it's out of bounds. So if R is less than 0, or R is greater than plane plane the length greater than or equal to plane the length, then I want to return something. I'm not sure what I'm returning yet. And I also want to do this for C as well. So if C is less than 0, or C is greater than or equal to plane 0 the length, something like that, I want to return something as well, right? Okay. So this checks if I'm out of bounds. So out of bounds. There's another check for obstacles, right? So if there's an obstacle, I want to also return something. So if our plane, how do I present an obstacle in my find list? I want to assume that I represent an obstacle as, in my question, I used, so in the example, I used asterisk and I used dash. Should we do that? Should we continue using that? Or should I use -1? I think I can use -1 for obstacles. So if plane if the current position is an obstacle, so if it's -1, I want to also return something. So what do we return? So if like at this point, we're returning I think we can return 0 if we find our position. And then for every other one, we can return like 1 or something, right? Yeah. And at this point, I would just do int distance. I would make distance. What would I make distance here? I can make it like, I can make it 2 or something, right? And I do distance is equal to math the mean math the mean distance and this. So the basic reason I'm doing this is because, so distance, I'm not sure if this makes sense, but yeah, let's see. Distance is 2 because I'm returning, the highest value I'm ever returning is 1. And so I'm expecting that no matter where I get like, as long as I would always return one of these guys, no matter the path I go down. So find distance would always reach one of these three. As long as it reaches one of these three, it means that distance. Sorry. Hello. Um, There's someone unmuted. Damilola. Okay, cool. Thanks. So I was saying that I'm making distance 2 because the highest I'm ever returning is 1. So math mean would always give me one of these values at each point, right? Yeah, so I just keep doing that. Math mean distance, and I do that again. Just going to copy this because it's kind of the same thing. Right. I also want to check if someone is visited, right? So if the place I'm trying to go to has been visited already in this place at this point, I want to also return 1. Yeah. Okay, cool. And this should, so basically I get the distance from here. Now if, oh, no, that is wrong. That's wrong because I'm trying to get distance. What am I doing? What am I doing? I need to, as I go on, I need to increment this thing by 1. So I need to return something different. So what do I return? If I return integer the max here, it would, okay, because the point is, so I'm in a 10 by 10 plane, right? So the highest thing I could ever return is, even if I visited each point in the plane to get to the distance, the highest distance I could ever return is 100, right? Because 10 times 10, right? So possibly I could return
Hello, Ayo.
yeah, hi.
Yes. Remember,
Sorry,
we're calling find, are we calling find distance for each of the four
sorry, I can't hear
possible?
you.
Are we calling find distance for each of the four possible positions that we can move to?
I might say this again.
Are we calling the method find distance for each of the four possible positions that we can move to?
I can't hear. Does someone hear him? Am I calling find distance for what? Sorry.
I think he said, are you calling find distance for each of the possible
Yeah, exactly.
moves? So,
Yeah, that's what
yeah.
I'm doing.
Yeah.
Yeah, that's what I'm doing. That's what I'm doing. Come on, 1 sec.
Okay, I think if we're doing that, right, the largest distance can be 1.
The larger
The
distance can be
largest,
what?
if there's a distance between 2 points, right, we should return a 1. which means we can move forward. I don't know if that makes sense.
Sorry, does someone mind like saying it again?
Okay.
No, yeah, I can't really hear you. Like your thing is a bit muffled for me.
Okay, I'm saying, can you hear me clearly now?
Kind of, yeah. Can you talk slowly?
Okay, I'm saying if there is a distance between 2 points, right, we should return in one. If there's
Right.
like yeah, I think that makes sense, which means we can move to that position.
Right.
Then if it's maybe out of bounds, right, we should
Yeah.
return a zero, which says we can't go there. If it's visited, we should return a zero, which says we
No.
can't go there.
Yeah. So if it's visited and it's out of bounds and we return zero, like the main
Yeah.
issue here for me is that I'm trying to get the shortest distance, right? So what I'm doing at each point is to try and get the minimum distance to the point, right?
Okay.
That I can get to. So if I return zero, like the way the algorithm is set up right now, it is going to it's going to basically get deceived, because if I return zero, it means that my distance has not increased. Does that make sense? So I need a clear distinction between when I am checking distance for a path that actually gets to a like the node I'm looking for, and like between that path and a path that doesn't get to the position I'm looking for, right? So for example, when I visit, that means I'm like, when I have visited a node, it means that that path is not valid. So I cannot visit that path again. When it is out of bounds, it means that path is not valid. But if I return zero as is, the problem is that because I'm finding mean, because I'm not adding any, because I'm returning zero, then like zero is going to be the minimum value. I don't know how to explain. Like zero is going to be the minimum value, like the mean value I can ever get. But I'm trying to get minimum distance. But zero, like if I return zero for visited, that's going to like be deceptive here, because this would see that zero as the minimum, but that's not the case for what we actually want, because what I actually want is to find a minimum distance to the position I'm looking for. So if the path is visited, I was saying that one thing that we could potentially return is if you have a 10 by 10 matrix, the largest distance you can ever visit, or largest distance you can ever traverse, like around the matrix, is 100, right? Like if you visited every single node. So I was thinking that for each of these illegal paths, we just make the distance really high, like 101 or something. So we know that as long as our node is within the matrix, the length of the distance would always be less than 100 or equal to 100. Like, does that make sense? I'm not sure this is the best way actually though, but I mean, there might be a better way. If someone knows a better way, please let me know. But let me know if this makes sense at all to you. So I'm basically saying I am returning the same result for this guy. Maybe I should separate it actually. But yeah, this might not be the best way out of this. There might be a better way. If anyone knows a better way, please let me know. So what this basically means is that as long as the path is invalid, I'm always going to be returning. I'm going to return like a larger distance than what is actually possible. So in a 10 by 10 matrix, the largest distance I can possibly get is 100. So here I'm saying that I want to return 101 for a distance for like any node that is illegal, right? Any place that is illegal. So it means that as long as I have a valid path, the valid path distance is always going to be less than the illegal path distance. Does that make any sense? But
Yeah, it's making sense. Okay.
So I basically now find right. Okay, so here I need an extra check. So if distance, right, is equal to yeah, it doesn't matter actually. Yeah, it doesn't matter. So that's fine. That should work. So yeah, this should work, I think. How can we test this? We can test with our example from here, from before, this one, 3, 4. So we said the shortest distance is 5, right? I'm just going to, this is going to be here. So if anyone thinks of any edge cases, please feel free to let me know in the chat. Let's test it together. This might not be right. It might be right. I don't know. But I want to assume it is. All right. So let us represent this guy. So we have int. We have the plane, right? Then I think we can just define in Java. We can do this. So the valid position will be 0. I just have 0. Ah, interesting. So coming. Okay, that's fine. So 0, 1, sorry, 0, 0, 0, 0. Then 0, 0. This is an obstacle, so -1, 0. Then do we have an obstacle? Yeah, we have an obstacle here, 0. Then 0, 0, 0, 0. This. So we don't need to specially mark any point A and B here because yeah, we just already have the points. But technically we could mark, we could actually mark it A like this or something, like if we're using a character, yeah, like a character multi-dimensional array, but it doesn't matter here, I think. So we have this guy and we know that our point is, so we basically just print out system, the println, the call, shortest distance to plane. What's our R and C? So R and C 1, 1. Then the position we're looking for is 3, 4, right? Okay, so let's see how this works. Are we doing anything here? We're not returning. Why am I doing this? Return. Yeah, I need to actually, something I didn't ask was what to return when we don't find the value in the, I want to assume it's always there, sure, but yeah, what to return when we don't find the value. So let's see, sure. Where is this? 55. Where's 55? You. Cannot find symbol. So I'm calling something that I haven't passed in. That's weird. Visited. Oh, nice. Master mean no valid, no suitable method. So do I need to import something? Yeah, I probably do. Import math Java. I don't have to be static. Max. Am I using mean? I think it's mean I'm using. Yep. Did not find symbol. Math domain in Java is math in Java. What's going on here? Okay, static is not the problem. No suitable method found. Are you telling me the import isn't working or what? 72. Oh. Okay. So we're going index of the bounds somewhere. 44. So we want to check out the bounds first, don't we? We also want to check if it's an obstacle first before we start. Cannot find symbol. Is there any symbol that is not? What does that mean? Okay, 8. 8. Okay. So this is returning 8 to us. It's also taking a while. I can probably make that faster, to be honest. So this is saying 8. So how do we get 8 again? So we go from here to here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. I think it's going the other, like it's finding the other path, for some reason not returning the minimum path. Right. Something that could be helpful is to, oh, that is so weird. Did I pass R1, T1? Okay, yeah, that's correct. That's fine. Um, so this is returning 8. I want to try and see if I can print the path. It would have been easier to do this with an IDE so that I could see what is being printed. But yeah, we don't have that. I don't have that in an interview too. But anyway, so let's try and see if we can find what the problem is. So I declare like a visited array with the same size as a plane. I don't even think I need a visited array, to be honest. I think if I can just say, yeah, if it's an obstacle or plane RC is equal to 1, then I'm going to just comment this guy out. So I'll use the same matrix to mark as visited or not. So the assumption is that everywhere that is not visited is marked as 0, and I can mark it as 1 as I go. So we actually don't need visited, right? And yeah, I'll just remove that guy. All right, cool. So I don't need visited. So I go find distance. I want to find distance between this point and this point. Shortest distance. So I find distance. All right. I check if they're equal. If they're equal, just return 1. If they're not equal, I come check it out of bounds. Am I checking the right way? If r is less than 0 or r is greater than or equal to plane the length, right? Or c is less than 0 or c is greater than or equal to plane 0 the length, right? I want to return the maximum I can possibly return, obstacle or visited. So if I'm either encountered an obstacle or visited this place before, I want to return maximum. That seems right. Then if none of this is true, then I want to like see if I can find the path again. So I mark the place as visited, then I check I set like a current distance to 1. Yeah. Then I now want to check, I now want to find the minimum distance. So I now find distance, I go left, try and see if I can find the point. I go right, try and see if I can find, I go up, I go down. Then I mark as unvisited. Then I return current dist dot dist plus this. That seems right to me, so I'm not sure what's going on here. Does anyone see anything wrong with this stuff? Something we can change? I don't know why this stuff keeps throwing an error. 42, what's 42? One, one. Oh, 3, 4. Wait, 0, 1, 2, 3. That's funny. So this is 2, 4, right? 0, 1, 2, 4. Yeah, we should probably use examples. Should have examples from for next time. The 2, 4 is 7. It still doesn't change anything. Well, reduces it by 1. But
Yeah, I think it's 2, 3. Yeah.
oh, That's actually weird. Oh, right. So what was he doing? Right, it's 2-3. It's actually 2-3. But what was he doing though? If it's returning 7 for 2-7 for 2-4, why was he doing that? Because 2-4 is out of bounds basically. So it is returning 0, 1, 2, 0, 1, 2, 3, 4. If it's out of bounds, what should he do? It should return plain length times plain length plus 1 at least. So we should at least have 16 as an answer if like that's valid. This is returning 6. So there's something wrong with this that I can't see right now. We don't need this guy. There's something wrong with this I can't see right now.
I think what can help is keeping a list of the predecessors so that we see where how it moves.
Yeah, we can do that. So let's try that actually. I can do a list. I can do a list of what a list of lists. I can just call this pre-path or something, right? New array list. Let's see what's going on. All right, let's go. So path in here, take you. Then I do this. Then I basically pass path everywhere. Path, 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 path. Right, and the main thing is I want to print path out here first. Path. Cool. All right, so now how do I fill the path? So I basically would, if this place is not visited, I just would add it. So create a list of integers, call them position, call it new array list. I feel like there might be a faster way to do this, but oh well. Think into array. Position dot add r at c. Okay. Then I want to do I wonder if okay, yeah, it would work. So path
Position, yeah.
yeah, that should work. Let's try that. Cannot find list, cannot find symbol. Oh, what I have to import for list again? Is it util? I think util something.
Java.util.
Right. So import java.util. Thank you. Cannot find symbol, class list. Is there something else? Oh, there isn't. I want to understand something. It looks like there are a lot of repetitions here. I feel like I might be visiting places more than once. Okay, I hope not. So 1101001000. Okay, so we're not. That's good. That's good. So what's the minimum we can see here though? 1, 2, 3, 4, 5, 6, 7, 8, 9. Where are we going? 2, 3, right? I think that, yeah, I want to remove, right. I need to remove heat at the end of this guy, right? I need to remove, yeah. If I add it there, I need to remove it because now we're not using that position anymore. Right. Okay, so we see 1, 2, 3, 4, 5, 6. So 6 is the shortest. So what's the path that it is seeing? So it is seeing, I go from here to 1, 1. No, yeah, from here. So this is, oh, it's counting 1, 1, right? So 1, 1 is counted as 1. Oh, I see. I see. Right, I see. 1, 1 is counted as 1. Right, because, yeah, interesting. So it should be 5. Yep, okay, cool. So 1, 1 was being counted as well, like the starting position was counted as a position. I think that was the problem because here it doesn't make a distinction when it is, and the first distance we're sending in there is the first position. So yeah, it doesn't count it. So it counts it as the first distance, but that was incorrect. So if it starts at 1, 1, let's go. So it goes to 0, 1, which is good. Then it goes to 0, 2. Where's 1, 1? This is 1, 1. Okay, it goes to 0, 1, it goes up. It goes to 0, 2, which is this. It goes to 0, 3, which is this. Then 1, 3, then the position. Exactly. Cool. So yeah, that looks like it works, I think. So if I'm just going to send this link to the group. If anyone thinks of an edge case that doesn't work, please let me know. But yeah, like before the next time, I guess there's going to be an announcement. So we're going to like create like hackathons with questions, and those would be like the questions we I guess solve in the during the calls, right? But if they're like interesting questions, before next time, I'll try to collect the questions and maybe create a poll or something. I think you can do that on Slack so that we can know what to focus on. I would also try to look through like questions on the sheets and collate them. Questions on the sheets and collate them so that the similar ones are not repeated. Is it possible to have any day aside Saturday? Yeah, I mean it's possible, right? But I guess work is a bit constraining here. But yeah, it's
Hello,
possible.
Ayomide. Hello, Ayomide.
Hi.
So our time is up now. Maybe we can just open the floor for questions and answers.
Sure.
So guys, if you have questions, we can unmute ourselves, and concerning the class, we can unmute ourselves and ask Ayomide, or we can just drop it on the chat box so that I can answer them.
Okay, I just have just something basic like practically if you get something like this, but not like in an interview, let's say in like an online assessment, how would you go about solving this very, very fast? Because like I got a very, very difficult question in an online assessment yesterday, and I had just 10 minutes. Like the timer was ticking. Was one of these online assessment solutions. It's called Coding Game. It's very, very familiar with European companies. I got a very hard question in like 10 minutes. I didn't even, before I could even read the question and get what they were asking for, the time was already up, and that was it. I lost all the marks for that particular question. I was able to do the rest. But all in all, I had 30 questions, and I was only able to do like 19, and I still failed the assessment. So I'm just wondering, when you get like difficult questions in online assessments and you have a limited time, how do you go about solving them very fast?
So there are two phases to that. I'll focus on, I guess, the things you can improve, and then I'll talk more generally. So, like for yourself, I think that the way to improve is practice. I don't think there's any way around it. As you practice, there are like people that like participate in competitive programming competitions. The way they solve questions so quickly is by having like presets, right? So they have specific, like when they see like some types of questions, that they know that there's a specific algorithm, and you write it the same way every time. And so what they would just have is a place where they store all of these things. So yeah, I don't know that. I don't know like what kind of questions you get asked on like an online assessment. But if you find that you're repeating like a huge number like of algorithms this like frequently, then maybe it's like might be useful to have them stored somewhere. I know there are some assessments that don't allow you like move away from the screen, but a lot of them do. And so for the ones that do, you can like if you have those presets somewhere, then you don't have to waste time writing them. That said, so yeah, I think practice and maybe having presets might help, but practice is probably the most helpful thing here. The other thing is, so the way you practice, like you need to practice in the same, like put yourself in the same scenario as what you're going to experience, right? So if you're solving questions in 10, 15, 20 minutes, try to give yourself question, like when you're practicing, put yourself in that kind of scenario where you have 10, 15 minutes to solve a question you've never seen before. Try it with like varying complexity, like problem complexity, and see how well you do. Like those would probably be like good signals for helping you improve. But then more generally, it doesn't sound reasonable to me that you have 10 questions to solve a question like this. If you have a question, I don't know what kind of question they asked you, right? But if it's a question like this one, 10 minutes doesn't sound reasonable to me, right? So there's also that. Yeah.
Any
Any
other
other questions?
questions? If you are too shy to talk, you can just drop your comments. You can drop your questions in the chat box. So Shaolu Damilola, don't worry, I'll answer your question. Okay, I think somebody is asking, can you do this without a second array, Ayomide?
What second array is that? I mean, yeah, I think we did that. Like we remove this. Do you mean like visited? We remove visited, right? Is that what you mean?
Okay, Chuku, are you still on the
That's
call?
what I mean. Yeah, I didn't see that you removed this. So yeah, that's what I meant.
Yeah. So we use the same plain one, the same plain array to do that.
Okay.
Cool. So I'll send this link to the group. I think it's public. So yeah, let me know like if you have any other questions. We'll make announcements later. If you have questions, please tag me in the group. Thank you.
All right, everybody would like us to please appreciate Ayomide. Thank you very much for your time. We are really grateful to have you, for coming around to share your knowledge with us. That means a lot. So I'd like to take feedback, but we'll be sending that to the group chat, Slack channel. So please appreciate all of us to fill the survey to let us know what you like us to improve on, and any feedback at all. We'd like to hear from you. Thank you very much. So like
Yeah.
Ayomide said, if you have questions that you cannot ask here, you can please drop it on the Slack channel and tag him.
Yes, please. And yeah, your feedback is really important, right? This is meant to be helpful for you. So if we can do this in a better way, yeah, please let us know. Like, it's really important. So yeah, thank you.
All right, thank you very much, Ayomide. Thank you everybody for joining us. We would let you know when next we'll be having this class, and we'd love to have you more. Thank you very much, everybody. Have a lovely day.
All right, thanks.
Thank
Bye.
you. Thank you, Ayomide. Thank you, Thames. Bye.
Bye
Bye.
bye.
Thanks.
Bye bye.